Thanks, Megan. So yes, as we go forward, I'll try to pause as we go through. And Megan, if you'll just let me know if you've gotten something through chat. It's hard to keep an eye on that as we go. So yes, my name is Lisa Kurowski. I'm a senior business analyst in NetApp IT. I have a couple of hats, two of which I'm going to talk a bit more about in this conversation. I'm the process owner for configuration management within IT, and I also am the integration prime for portal-related automation, specifically that's going to have a ServiceNow front end to it. And so I'm going to start just by talking about the title of my presentation, because when I first put it together, I called it NetApp IT's Journey to Maturity. And then as I began to put together sort of my key thoughts, I thought, well, it's really towards maturity. Unlike other agile processes where you can kind of set out, do transformation, and achieve maturity, the CMDB is really quite a different animal. And so I decided that the best approach is to talk about how we can move towards maturity, because it seems to be a bit of an elusive thing depending on your scope. There we go. So a couple thoughts before we dive in. You know, as I said, CMDB is really different than other ITIL processes because what you put into your CMDB is sort of ever expansive. Is your goal to put servers and user devices? Are you aiming to get peripheral equipment from conference rooms? Are you after software versus hardware? Are you after storage? And so in terms of, you know, trying to build a mature CMDB, it really is a bit of an elusive thing because you want to start small and mature in an iterative process. It's really important to prioritize how you're going to lay the foundation for your CMDB and then sort of build out from that. And we really spent, you know, a good amount of time talking continuously about what's important versus what's nice to have. Because it's really easy to put data in your CMDB. It's really difficult to keep it current. And as soon as you dump data into your CMDB that is not kept current and your users figure it out, they will immediately lose confidence. And the challenge with the CMDB, because it's often so broad, you have different users that are using it for different reasons. And so if a user is using it for one purpose and they find that piece of data to be inconsistent or out of date, and they begin to spread the word. They may only be talking about a small piece of the CMDB, but in general, people just call it the CMDB, right? It has many different things in it, many different uses. And so I would really encourage you as you move through your journey to mature your CMDB in an iterative process. Decide, you know, what pieces you want to add on and try to build a core foundation that you can build up on. We made a conscious decision early on to automate and standardize wherever we could. And those are really key, important decisions to try to keep that data sound so that it can really be your source of truth. It's also really important to focus on data ownership, which can be kind of challenging given the scope and the size perhaps of your CMDB. And you know, some groups of data don't fit. You know, like an application, you can have an individual owner. When you start talking about other data like hardware, it might be more of a group. So data ownership doesn't necessarily mean that it's owned by individual people. We have a follow the sun model of support from an operations perspective. So clearly we're not going to be tagging individual devices to individual people, but understanding the overall structure of your CMDB and understanding how the data gets in and who's going to fundamentally own it, even if it's at a group level, is a really important concept. Additionally, when I say, you know, think about the whole life cycle, again, it's really easy to dump your data in, and then if you can overcome that next step to keep it maintained, that's good. But sometimes we forget about retirement, and I'm speaking specifically about us. When we started our journey, we were very focused on how to get data in there and how to keep it maintained. We really didn't think about a structured retirement process for the assets when they reached end of life. And it really became a challenge point for us because it meant that we began to kind of abandon pieces of data. So it's really important to really think about it from the end-to-end cycle. And the last sort of high-level point that I would start with would be concurrent maturity. The whole point of putting a CMDB in is to be able to use it. And typically you're going to integrate that with something, like you want to integrate it with incident and change management. And you can't do that if your incident and change management processes aren't mature. What if you want to integrate it, say, with your network ops and their processes and tools aren't mature? You're not going to be particularly successful. So you have to find that compatibility in maturity. And the same thing is true in terms of integrating things into the CMDB. You can't really begin dumping in storage data or network data from alternate sources if your CMDB itself is not yet mature. So there is this pathway that you need to find to mature your CMDB and think about your integrations in terms of whether or not your CMDB is mature enough to accept that integration, or conversely, if you want to integrate into something else, is it sufficiently mature to allow that integration? So I like to start with this eye chart. This is eye chart number 1. This is a capabilities map for ServiceNow. We are a big ServiceNow team. When we first started this, we implemented it with incident, change, and problem management. And then we expanded pretty quickly into building a self-service portal. And so therefore, when we had the business need to build a CMDB, it made a lot of sense for us to leverage ServiceNow and its CMDB and its discovery mechanisms. Because this gave us a couple of advantages that we didn't have with our homegrown CMDB. Our original CMDB was used by a small number of people, primarily in the data center area. So it did a great job of tracking their infrastructure, but it wasn't very usable. It did widespread scope. It couldn't be seen and used very much by the entire organization. In particular, the ops organization didn't have full access to it. Most application people didn't have access to it, didn't necessarily know it even existed. And it wasn't in a state that really allowed us to then use it in key things like incident and change management. So choosing ServiceNow for us was really important because it then has allowed us to leverage lots of other tools and integration points. So for us, our CMDB journey started with building a new production data center and the need to migrate everything that was production oriented from other data centers. The good news is that gave us really a common focus and goal across IT to have really good solid data. You can't move from one data center to another unless you know what you have and what's running on it. Heaven forbid you should start pulling down your physical equipment in one data center to spin it up in the other, and you don't know which applications you've just impacted. So it gave us a really good goal and reason to be commonly aligned to understanding what we had, which is really important. It also let us think about laying the groundwork for a lot of things that will make you successful with a CMDB in terms of re-engineering some of our standards and moving away from a lot of the manual effort that was associated with our work. Just to give you a bit of a view of how big our CMDB is, it wasn't this big when we first started. If you're familiar with ServiceNow, they leverage what's called a class. So each major type of data that you manage is called a class. Each thing that you put into that, each desktop or each server, each blade, each application is a configuration item. And then the things that tie it together that make it more than just a giant inventory are the relationships. Those are the things that say this application is running on this server is running on this piece of equipment is in this rack, which is in this room. So ServiceNow uses the constructs, and so we had probably 100 classes when we first started. We're up to around 240, and that's the number of classes that are actively getting data. Probably on a day-to-day basis across the primary users, we probably use closer to the realm of 30 or 40 on a consistent basis, but you can drill in to those data elements and acquire a lot more knowledge about them. People get a little hysterical when they see I've put on here that we have 16 data centers. So we really have 2 major data centers. But we also count, ServiceNow counts, every data center as a data center. So if we have things in the public cloud, AWS, Google, and Azure, those are all data centers as far as the CMDB is concerned. We also have smaller regional sites and field offices and colos that, as far as the CMDB is concerned, also count as data centers. So if we count all of those, including private clouds, which sit alongside our traditional on-prem, we have 16 data centers, even though we will really say that we have 2 major data centers. Physical equipment wise, around 3,500 devices, around 5,300 logical servers in the infrastructure layer with a growing presence within the cloud. And everything that wants to use one gets registered as an application. Again, if you went back to our enterprise architecture team, we have a much smaller set of core applications that run our business. But this is the total number of things that would be registered as an application. And I like this model. This is a model I put together, and we'll see it again in greater detail because it helped me when I first joined and was asked to provide some governance and leadership around the CMDB to understand and communicate what's in the CMDB. Because again, when you talk to ops people, they think of the CMDB as mostly being this stuff right here in the logical layer. If you go talk to data center services, the CMDB is pretty much this stuff down here. If you go talk with an apps guy, he lives up here in the application world with his databases and his app and a little bit of his infrastructure. But to everybody, the CMDB is something different, and it's so big. It's really good and important to have a map and a model of what you have so that you can help people understand what's in the CMDB and what's mature. Also, like really dividing it into these, what things are logical and what things are physical, as well as if you can kind of figure out where you are in this layered model, you can kind of figure out where that data is probably coming from and how it's managed. A couple of key principles that we put in place when we first implemented were to leverage ServiceNow Discovery. ServiceNow Discovery is going to play into this layer right here and find all the logical stuff. For our goal was to be as hands-off as possible in terms of putting things in. So automation and a really big push now towards self-service automation were our big key. And as a last resort, manage your data manually. There's always going to be things that you have to do manually. The status of your physical infrastructure is probably going to be turned on and off manually. And application registration, who your contact points aren't things that you can go out and scan and collect. It can be things that you have to get from a manual perspective. But the key would be, I think, from a prioritization perspective, to look at where you can do automation discovery and to do self-service as much as possible. So one of the other things is that you shouldn't think of your CMDB in isolation. From the outset of our implementation, there were a lot of extraneous things within ServiceNow that we took advantage of. You want to use the models database in order to create consistent baseline for the various hardware and logical server components that you add. We also built a provisioning catalog using just your native ServiceNow catalog capabilities for data center services from the beginning. Again, our driver was to build a new production data center, and that meant spinning up new equipment quickly. So we gave them a catalog that's integrated with the CMDB. Basically, when a piece of equipment comes at the door, they can go there and provision a new piece of network equipment or a new blade or a new physical server. It walks them through the process, and the CI is added to the CMDB as they go and acquires additional attributes as they progress through the provisioning. So it's kind of key to have a lot of those front-end catalog items directly plugged into the CMDB. Again, even from the beginning, we put into place some basic provisioning. automation. And that catalog, as rudimentary as it is still in place today for our on-prem provisioning. We have a better, newer catalog for cloud management, but the original catalog is still in place, tied into the CMDB, so that as things are ordered, they're automatically put into the CMDB. And then the front end to application layer is self-service registration. Just puts management of that data into the hands of the individual application owners and puts them in the position where they need to maintain that content. So your help desk and other teams who want to understand who are the contact points for this application, they can register their applications and they can maintain that content. We have lots of other catalog front ends at this point that tie in and leverage the CMDB. We have a major program called Cloud One that has a lot of different components that are directly tied in. So CMDB really doesn't sit in isolation. Even from the outset, you ought to try to tie it into your catalog front ends to begin the life cycle of your CIs. A lot of automation that sits behind those catalogs in order to provision logical servers, storage, and load balancers. We still have WFA in use, as well as Ansible Tower. For network device and discovery integrations, we're using an integration with Python. And so all that really ties together your CMDB, which is going to tie from top to bottom with the data that hopefully you're going to get either through your front-end automation or through something like discovery. So this is my second eye chart. I actually put this chart together in combination with that simpler model that you saw in the beginning. I put this together probably 8 years ago, and it fundamentally has not changed. What has changed is that more things have arrived here. There's 240 classes in the CMDB. There's no intent to represent them all here. I can tell you where they all fit in this layered model, but there's no need generally to represent 100% of them. But the point of putting this together was it tells me a couple of things, right? It takes my major classes of data and tells me whether or not they are, physical things that I'm tracking or logical things that I'm tracking, things that I can put my hands on and things that, I'm not actually going to be able to touch and feel with my hands. It also tells me fundamentally who's responsible for that data and in general where it's going to come from. So I'm going to start at the bottom, and if you're not familiar with ServiceNow, you think of every box as a class of data, and the lines that join the boxes are the relationships. So these are stored within the CMDB as relationships that help you understand dependencies between your databases, between your individual CIs. And if you don't have the relationships, then you really have an inventory less than you have an actual CMDB. It's the relationships that really turn it into a CMDB that lets you understand how the pieces and the parts fit together. For us, the core path for this was to mature application, logical infrastructure, physical infrastructure, and the ServiceNow. That was our starting point, with a lot of this data here in the data center and in the equipment being the most stable and mature data that we started with. Discovery comes in and plays a huge part here in the green layer, because I would say that if we look at the scope of the CIs that are in the CMDB, probably 90% of the data in the CMDB is actually in this green layer. All the things that you can learn about servers through discovery, including their processes and their IPs and physical configurations, what patches and what software are running on them. So a single server discovered, right, can turn into potentially a couple hundred CIs added to the CMDB, linked together through relationships. So maybe if we just walk from the bottom up, the bottom layer is our data center layer. It's an abstraction of our data centers from the actual physical building into the individual rooms and zones and racks. This data is pretty stable for most people. It's owned by a very limited number of people, usually your data center architects. And we didn't front this with anything fancy because it's generally stable. as we move up the layer, the quantity of data increases. So this is our physical infrastructure, again, maintained by data center services, to some extent manually, but mostly through the service catalog. So the service catalog, again, lets them take a piece of equipment that's come on the dock and walk it through the provisioning process. And at the conclusion of the provisioning process, there's a CI in the CMDB properly tied into the rack with all the attributes that they then need to manage that asset. And when they do a physical inventory, they will do a reconciliation back to the CMDB. And the catalog helps them build out the relationships between blades and enclosures and controllers and shelves. So, the two key things that you have to think about is how do I get the data in there, and then how do I get it related? So our service catalog for hardware helps us create that. Again, when we move up to this layer, this layer is probably 95% of the actual data within the CMDB, with the predominance of that data coming in through discovery. But technically the front end to a lot of this over here is going to be those catalogs. So I need to provision a new Windows or Linux or Solaris server. I'm going to create that CI at the moment that provisioning starts, following a standard naming convention that allows it to fit within my infrastructure. We use ServiceNow Discovery to create all the lines from this box down. Of course, there's some more complexity here because a virtualized server is really running on top of an ESX. And the benefit of using Discovery is that it actually hits the vCenter, tells us all the fun details about the vCenter and the data stores, all of the hypervisors, and the virtual machines, and helps us create those connections. But the connections to get from the green box down to a yellow box, we base upon serial number matching. So the data center services is responsible for all of the assets down here in the data center, keeping track of which serial numbers they have. And when Discovery runs, one of the questions that it asks each device is serial number. So you can use serial number matching to automatically create these relationships, and then this doesn't become a manual interaction. So most of this data comes in through Discovery. And again, our initial investment in maturing the CMDB was to be somewhat narrowly focused. This is the predominance of what people need to use from an operations perspective. It's the key tie point for storage. It's the key point for application hosting. So it was our primary focus for a good probably 18 months to try to get this path from application to server down into the infrastructure as sound and complete as we can. We scan our infrastructure once a day. So everything that we know is in the CMDB, we hit once a day so that it's up to date. But we're also integrated with Infoblox. So we obtain the IT subnet information, and every other week we scan every subnet that IT is responsible for. And in that way, we can collect other assets that may have come in to the network through different processes. And then it's easy to take a look at what's come in through those full scans. If they have followed the IT standards, things all work great because these will connect automatically down, and we have a naming convention in our infrastructure that allows them to create automatic upward connections to their applications. If they didn't, we have a list that comes out from those full scans. We take them back to the teams that have the ability to add things to the network and get them to reconcile them so that we can minimize the quantity of manual work that we have to do. And this work here, though, the original mapping of applications to infrastructure was a fairly large challenge. In fact, it probably took us close to a year just to get all of the applications claimed. So we had this master list of applications. We weren't 100% sure what they ran on, but worse yet, we had a challenge getting people to actually stand up and say, I am the prime for that individual application. That's why application registration was really important for us, because we wanted people to take ownership of them. We found that sometimes people want to abandon them, right? I'm done with that application, so I'm just going to walk away. I don't own that anymore. I'm not going to pay attention to the infrastructure that sits underneath it. And so having clear application prime contacts, we actually have a quarterly process there we send out a notification that says, you know, it's time to review your application and your contacts, and they need to certify that those contact points and information are accurate. This is a point when people will typically try to come forward and say, I've retired my application, so why do I have to keep reviewing it? Well, as long as you have infrastructure tied to it, it's not actually retired. So it's an important part of the process, and this was sort of our core path. Mature the application, its linkages to the infrastructure, its linkages to the physical infrastructure, down into the data center, and from that, you know, we could build. Our next building area was into storage, so we weren't very happy with ServiceNow's storage scanning capabilities. So we decided that OnCommand Insight was the tool that we use for storage operations. It became our source of truth there for storage data. We built a connector into the OCIE data warehouse and pull over sufficient data that lets us do CMDB-like things, right? So the things we want to do in the CMDB are, how do things tie together, right? If I have an issue in the physical infrastructure that supports storage, can I walk up the tree and determine which servers and therefore which applications are going to be impacted? What we're not trying to do is replace the operational component of OCI, right? We would need enough data in here that we can ask bottom-up questions and top-down questions. I have a server that needs to be refreshed and rebuilt. What storage is it dependent upon? I have an application I want to retire. How much infrastructure and how much storage is associated with that? How much benefits will I be able to get by taking it out? What if I need to move it to a whole new location? So the whole key is to be able to have these connection points. Without this connection point here, you really don't know the usage, and you can't really do that change management planning or that incident planning. So I would say that you know, our first pass was here, our second pass was in storage, our third pass was in the realm of network equipment. To build an integrated process to come to the CMDB and say, I'd like to onboard a new piece of network equipment and have that represented in the CMDB as well as the network ops tools, was our next big step. And then we discovered that, you know, even though we did that, now we have these great F5 big IPs represented with all their services and their pools and their load balance pool members, it still didn't really tell you who was using it. Out of the box, ServiceNow does a great job at giving you these details, but this connection piece right here is the critical piece. Well, if this load balancer is not working, who am I going to go back to? If I think I have load balancers that don't appear to be being used. And one of the ways that can happen is if you deprovision all of the servers that were in the pool, you have a pool with a bunch of IPs that don't actually point to anything useful anymore. And so creating this connectivity here, which required maturity here, right? So now I can discover my services and my pools and my pool members. It will tell me the IPs that are in the pools. I can use this data here, which is mature. It tells me which IP goes to which server, and I can annotate the pools if I want, and then I can determine those servers are tied back to which application. So by definition, if an IP for server X is in the pool, that load balancer, which has that pool member, should be being used by that application. So this was an interesting mapping process because once it was in place, we had application primes who could then see load balancers that had IPs to their servers in them that perhaps were mistakes. And most of those mistakes were because servers had been deprovisioned, the IPs had been reused, but that IP had never been taken away from the original pool. Just gave us a good opportunity to leverage it and build more integrity into our overall decommissioning processes, especially for servers, as well as for load balancers. So do we have any questions before I kind of continue on? This chart can be a little bit busy, but for us, it's really been an important roadmap to understand fundamentally how the CMDB components fit together.
Lisa, at this point, there are no questions in the chat, but if you are on the line and if you'd like to ask a question, please take yourself off mute.
Okay, I will press on. I get a lot of questions about our OCIE integration. So this slide is representing a couple of things. Again, if you're familiar with ServiceNow, this concept of upstream and downstream relationships make sense, but just think of the chart we were just looking at. This is a logical server, so upstream from that is going to be the application, and downstream from that is, this is a virtual, so downstream is going to be an ESX. But as well as it's going to be the storage constructs. So the integration that we did with OCI pulls over the exports and ties them directly in. That allows us to visually see them. It allows us to use that data when we do impact analysis for changes. But one of the easy and but yet really important things that we did was tie in the OCI asset URL, so that when we have an outage or a crisis and they're digging into, okay, this server seems to be in trouble, do you think it's a storage problem? They can simply click on this URL and jump over to OCI, and OCI is going to give them a view as to the storage health. So we did this in other places as well. We also have URL tie-ins for Splunk. So you can sit on the server CI and click the Splunk URL and jump over to the dashboard. We've done some reverse annotation as well in OCI. If you know in CMDB that server X is used by application B, that relationship can be transferred over to OCI as well, because your operations guys for storage are going to tend to spend their whole day in OCI, but they may as well take advantage of the knowledge that you've built in the CMDB to be able to create those correlations. It also helps you on the OCI side be able to say, hey, this team has come back to me and asked me for more storage, but you know what? I can look in OCI and I can look at the CMDB at the volume of storage that you already have. Is that really a relevant action to go and grant additional storage? And this is my last eye chart, I promise, in terms of excessive detail. This is a dependency map that ServiceNow, this is actually a really old look and feel to it, but the concept remains the same. Basically what this does is just a visualization of what we were looking at a minute ago. It's focused on this virtual Windows server. And you know, each dot is a configuration, an individual configuration item with its class type itemized, and every line is a relationship. So this Linux Windows server is a virtualized server. Discovery tells me that, running on this ESX. Again, Discovery tells me that and relates it. OCI has told me that the ESX is using this storage. So if I have a problem here, I have a problem with this ESX, which means I'm going to have a problem with every virtual machine that sits above it. That ESX sits on a server, right, which ties down in. It's leveraging storage itself, primarily for application and data. The boot disk stuff is going to come from the data store. But this is going to be the actual application data that it's leveraging, which, you know, CMDB tells me if all the dots are connected, right, then I have the ability to traverse up and down the tree. I go up the tree to the application and the business services, and down the tree into the infrastructure. Did we have a question? I think I saw chat flash.
Nope, Lisa, it was just me putting information in there for insight.
Oh. Okay. So what's it look like if you're doing public cloud? You know, the previous eye chart that I had was for private cloud and for you know, your traditional on-prem. There's lots of stuff sitting beneath this. When you move to the cloud, what's the point, or how does it look different? You know, we still run Discovery. We still manage our content here for Linux and Windows servers, for load balancers. For us, our model for deploying to the cloud has been to retain ownership of our storage. So regardless of whether you sit in the cloud or you sit on-prem or in a private cloud, we maintain ownership of that storage, so that if we decide Amazon's not meeting our needs, or Google or Azure or any of the other clouds, we can, in theory, simply spin down this server and redirect our storage to the new server that gets spun up. So for us, the model doesn't look significantly different. Obviously, data center services has less of a base, a footprint of equipment to have to manage. But our OCIE integration is just the same. We're still leveraging that same data, still tying into servers, still tying up to applications. So it doesn't look significantly different. It just loses a lot of the on-prem related infrastructure. So in terms of integrations, integrations really come about as you cyclically mature your data. The first integrations that we did, once we had that path from application to logical server to physical infrastructure in place and solid, that was the time for us to do incident and change management integration, so that when you put in a ticket and you put in a particular item that's in trouble, it'll automatically tell you which applications are impacted. For change management, you want to know which applications are impacted. You also want to know who your approvers are going to be for those change requests, which is why it's important to have good, solid ownership of the application data. We also put in, I kind of skipped over this, we put in change management controls around application ownership. Again, we want people to maintain ownership of that, and if I want to transfer this application from one person to another, I don't want them to just be able to go in and say, well, Ryan now owns this, right? Sorry, Ryan, but I've moved on and you're now got to figure out what you're going to do with this application and the infrastructure that I don't much care about. So we did put change management in place so that the new application owner had to take ownership. It was a good opportunity to ensure that people didn't just flip something over the wall to somebody else. As we moved, we did have some concerted effort to move things from the business over to IT. It couldn't be flipped over to IT before IT really accepted the support agreement for that. Other integrations that we had from the beginning, I mentioned our Infoblox integrations have been a really important one for us. Not only helps us with the scanning, I can also look up an IP using that, and it will tell me, where it is within the infrastructure, identify, a specific location and data center that that particular asset belongs to. If you're familiar with ServiceNow, they've got a couple different kinds of scanning. We leverage the probe scanning, but we've leveraged a lot more of their pattern scans lately. AWS, being able to find out all the assets that are at AWS, including things that aren't necessarily server-based, right? So we can get their servers less functions and things like that. We're scanning Kubernetes. That's going to have a lot of assets that tend to come and go very quickly. And we, of course, scan VMware, which gives us all our vCenter data. You can do rack visualization and power calculations within ServiceNow, but we've been using the product for a long time, and they didn't have a good base of functionality in the beginning. So we built our own tool that's used by data center services and pulls that data out of the CMDB, including those model information that I mentioned. We actually put in to the models pictures of the front and back of each piece of equipment. So if I use the CMDB and I know there are X number of slots in a particular rack, I know which ones have been consumed by equipment and I know what they look like. You can actually create a picture of what the front and the back of the rack are going to look like. And that data all sources from the CMDB. We've done a lot of other integrations with Xenos and Splunk and Ansible in order to work from an operations perspective, collect logging and event management, and the integration I mentioned earlier with network asset management, which allows you to onboard a piece of network equipment and integrate that into CMDB, into monitoring, into HPNA for network management. And then conversely, we got smarter with that implementation to ensure that we put the end of life as well. So now you got the asset in the CMDB. You need to be able to take it back through its logical and physical decommissioning and have it take it out from all of those environments at the same time. So a couple of the things that we haven't really talked about, I think, from a maturing perspective. Again, we talked about the fact that you want to sort of take a core approach to what you want to mature. and included in that data ownership and roles. So I found that ServiceNow is much too open in its model for managing data. So we spent a lot of time focusing on how to create roles that enabled better data integrity management, and overlaid that, on the processes that we already had in place. So I won't really walk through this too much. This is sort of a sequential look at how we took the core foundation then extended it, right? We already talked about extending it to incorporate storage, integration with incident and change management. And we've had a couple of forays into the hybrid cloud automation. We built our own hybrid cloud automation with App Center on the back end. And ServiceNow then actually acquired the company who built that. We had a short foray onto the actual CMP that ServiceNow offers before we decided that it was a little bit too restrictive. It didn't allow us to put the kinds of standardization and the type of speed that we wanted in the tool. So we ended up building our own Cloud One infrastructure as a service tool. So let's see. So I did put a couple things in here because I'm asked lots of questions about infrastructure as a service and how you can tie that in, why it's important and ties into the maturity of your CMDB. Depends on, the focus of your CMDB, assuming that the primary infrastructure, application, logical infrastructure, physical infrastructure are the key focus, then this becomes quite important. So this is our infrastructure as a service tool. Allows self-service access for the application owners to come and build and manage their overall infrastructure. And I really just kind of wanted to focus in on things like the order form, right? So being able to have a CMDB that has a good, solid application portfolio lets us manage the security within infrastructure as a service, as well as our other Cloud One tools, because we know which applications have been registered and we have key contacts for each of those. And those contacts, again, through governance processes, don't get to disappear on us. So if we provision these assets and we tie it to that application, we always know where to go back. Even if folks leave the company, we have a leaver process that is really important for things like the applications. When a user leaves the company, usually their laptops and their physical equipment, the individual assets that they own revert to their manager's ownership. And the same thing applies in the CMDB. So for an application, if the owner of that application leaves the company, then that application rolls up to the manager's ownership, and they can go into the CMDB or through our self-service portal and realign ownership to some new person on their team. But we ensure, therefore, that we never end up with assets that aren't tied to an application or tied to an application that doesn't have current ownership anymore. So we use the CMDB to manage security, manage contacts, and then as the order form is filled out, in particular, a combination of the application, the landscape, and the component code builds the host name. We use a standardized host name that allows us to know which servers, just by looking at them, what their basic landscape is, with their component, which application they tie back to, and whether or not they're virtual or not virtual. And these CIs are put into the CMDB the minute the order is submitted, and they walk through the status of the order. So this is going to go in as on order, and it's going to go in change status to in build to built. Then we'll run it through discovery. And then we have a CI that you can go back and look at the history to and see exactly when it came in, exactly who ordered it by looking at its history. Also tie in the storage. So we allow them to order up to 4 storage volumes at order time. At this data is going to be tied at the moment you hit submit. It's going to be tied to the CMDB as well, or to the CI in the CMDB. The configuration items tied into the orders themselves, so you can go back and use your order system to determine, what was purchased or what was ordered when. This goes as far as everything that you do, right? We could tie every action that we take against that through a portal integration. We could tie back. So even the start, stops, and reboots, or anything that we offer through that front end is going to be tied into a CMD, into a CI in the CMDB. So you can go back to that CI and go find all of its orders and go look at the orders and understand which configuration item it came from. So it gives us much better end-to-end insight into the overall data. The data itself in the CMDB primarily comes from one of two sources. It's going to come from the initial order, and it's going to be augmented through discovery. We do have a couple of event collectors turned on. Those are kind of cool because unlike a discovery, which only runs once a day, event collectors tend to be pushing real-time data. So if you subscribe to ServiceNow's or to AWS's subscription, event subscription, you can get Power State real-time or pretty close to real-time. VMware also has a listener that allows you to push that data so your CMDB can be updated real-time with actual state. And that's just a view of the storage CIs in the CMDB. We've also tied in storage buckets. So teams that are building both cloud-aware applications as well as your traditional VM-based can order a bucket for their application that they can use for storing executables or storing database backups. And we typically try, when we want to add something unique to the CMDB, to find the class that most closely aligns. So ServiceNow has an object storage class. They don't have a NetApp bucket storage, right? But they have an object storage that we can abstract off of. So whenever we want to add something custom to the CMDB, we try to find the thing that's already there and extend off of that. So we do have a NetApp object storage that lets us track some of the attributes of a storage bucket that might be unique to either storage grid or to our implementation within IaaS. And then these CIs are tied back to the application as well. So we have lots of things that actually hang off of the application, right? We've got load balancers, we've got object storage, and we've got all your different kinds of infrastructure. And this is just another one of our interfaces. We also have more cloud-based applications are going to come through DevOps. So these are applications which are building cloud-aware applications. They're not necessarily going to be hosted on VMs, but instead, I think I have, these applications instead are going to be having components that run in pods or containers. And even in that environment, even though it's much more dynamic and it's completely different than that concept, I kind of think of this as like virtualization on virtualization, because these Linux servers are virtual servers, and they actually are broken up into multiple components as well, right? So they have multiple containers that are running on them, and they may be shared across multiple applications. So with some thought around how you instantiate your projects or your namespaces in Kubernetes, it's still possible if you pre-think it. It's still possible to implement some standards that allow you through automation to create automatic connections between the cloud components that are being built and the applications. And we did that again through that same naming convention, so that I can look at the namespace of this pod and I can tie it back to the cloud environment that I've built for that application, where that's their data development space, or their staging and production space, or their data spaces. I can tie those namespaces back to their environments and tie them back to an application. So I can tell where an application is dependent down to the container in the pod, where they're dependent upon a particular cluster. So even if you're moving out of the traditional VM-based world into, something like containers and pods, it's still quite possible to build your CMDB and to create those connections back to your application so that you can understand what you have. Of course, this is much more dynamic, right? These are going to come and go much more quickly. And unlike other parts of our CMDB, we don't typically ever delete any physical infrastructure. We don't delete the ESXs. We don't delete Linux or Windows servers. It's a big mistake if you do integration to then start deleting data when it goes away. What does a ticket look like that was tied to a Linux server that you deprovisioned and then deleted? Now you have a ticket that points to kind of nothing. We don't put tickets in on individual pods and containers. So we don't mind that these are going to delete away. However, these don't, right? These environments stay, and what pods and containers they're leveraging might come and go. So I'm fine with this data coming and going. I'm not fine with this data coming and going, right? And but I could use that as a connection point between your more dynamically created and destroyed assets within the cloud. So this pretty close to the end. I did put this in because if you're interested in any more about some of the Cloud One portals, as a part of Insight, there is a speed tour of all of our Cloud One user interfaces, as well as if you're interested in any of the details around the automation that went behind our infrastructure as a service. There's also a Insight presentation that I think is 1205. So I think that kind of wraps it up. Do we have any questions that we want to go through?
And again, if you have any questions for Lisa, please take yourself off of mute. Lisa, at this time, there are none in the chat.
Okay.
Will you be able to share the PowerPoint?
Sure.
Okay, great.
Yes, after this, we will be sending out the PowerPoint as well as the recording to those that attended, and we'll have it archived as well. And we'll also be sending out the feedback form.
Okay, great.
If you've got any questions, I'd love to answer them. To be fair, I think sometimes when we give these presentations, it's a little overwhelming. But, keep in mind, we've been doing this now for 8 years, and it really is important to take it in that cyclical approach, right? Choose what's really important to you. Start with that and build a core foundation. Then you can start extending out into your integrations and, acquiring additional content in your CMDB. But that's also kind of why it's hard to ever say your CMDB is 100% mature, right? Because we keep extending. Oh, let's do cloud, right? So now I need to do Kubernetes. Oh, let's go do network equipment, right?
I know. Now, from our perspective, we're not there yet. But I think we manage most of the backup environment for our enterprise. And one of the challenges that we have today is we do have some file equipment, we have some block, we have some object, including some cloud. But what we don't have is a good visibility on backup. We do have high-level data domain items and numbers and figures, but we don't have anything that ties to that, right? Like the appliances and the backups and how many of that. For us, on the storage side, that's still part of the storage domain, and we don't have a view into within the NetApp application, which is on-site management, or OCI.
I gotcha.
Yeah, so
Right.
that's a challenge for us. So we are okay, but today, you guys probably know, is that our backups is becoming more expensive than our block propositions. If you think about it, we're getting to a point where it is most costly to have backup than block. So we wanted to leverage a tool, like, for example, whether it's OCI or perhaps CI, which is an enhancement, a feature set enhancement to be able to capture some of that. But that is the challenge that we have today, to be able to have an end-to-end mapping of everything that we do within the
Right.
storage domain.
Right. So our integration currently in the CMDB is OCI. And that's because, keep in mind, I said we've been doing this for about 8 years from a CMDB perspective, and we did our integration into storage about 18 months to 2 years in. So at that point, CI, right, Cloud Insight didn't exist yet. So our integration is into OCI. When the integration that we built became the foundation for the connector, there's a simple connector that you can get if you have a CMDB and you have OCI. There is a simple free connector that you can get from the NetApp store, which will not create as much data as you saw on mine. There's a second connector that you can work with professional services on. But of course, you have to have OCI. We will eventually, NetApp IT is using CI as well, but we haven't swapped out our integration to CI as yet. So we're still integrated with OCI at the moment.
Okay.
From a CMDB perspective.
Okay. No, that's fine. I think for our perspective, it's just that piece. We're missing that piece to have the whole picture, because ideally you want to have a server endpoint on a VMware, and that server is being backed up somehow, somewhere, and we'll be able to have the ability to see, okay, the server is backed up 3-4 times, and this is how much it's cost because it's doing it, and things of that nature. Would be nice to have the capability to do that.
Right.
Okay, cool. But I think I appreciate the effort, and I think if you could share your PowerPoint presentation, that would be great.
Sure.
Thank you.
Anybody have any key challenges or other questions that you'd like to ask?
Again, if you have any questions, please take yourself off mute, or if you don't feel like asking, you can place it in chat and we can ask on your behalf. I think that's it, Lisa.
Okay. Well, thank you for your time.
All right. Thank you, everybody, for joining. We put in the thank you very much for your time today, Lisa, and for sharing the information. As we mentioned, we'll be sharing the recording as well as the slide deck for those that have attended. One thing that we did put in there was the link for Insight. So as Lisa mentioned in her call out, visit insight.netapp.com, which is occurring in 3 weeks from the 26th to the 29th. We look forward to seeing you all there virtually. With that, we'll go ahead and conclude the session and stop the recording. Thank you very much for everybody attending. Thank you, Lisa.
Thank you.
Everybody have a great day and stay safe.